So in this class I'm going to cover what polymorphism means in Java. So in Java there are basically two kinds of polymorphism. One is called as method overloading. It's also called as static polymorphism or compile time polymorphism. And the other is method overriding, which is also called as dynamic or runtime. And as the name implies, in method overriding, the method that gets executed is resolved at runtime. Whereas in overloading it is resolved at compile time, so you should be able to see which method gets executed in your Eclipse when you do method overloading. So in method overloading, two or more methods with the same name but different number or types of arguments are provided either in the same class or they can be provided in the subclass as well. The methods that are overloaded should have the same semantics. That means the meaning of the method should not change. Like let's say if you have a method called toString or a method called print, all the overloaded methods with print should do the same thing. That is they should print something. So you cannot change the semantic behavior of the overloaded methods. And then you have method overriding, which is done via inheritance. So a subclass will declare a method with the same argument types which are defined in the method in the superclass. And the behavior or the method which gets executed at runtime will be based on the actual object held by the object reference. Once I show you an example, this will be clear to you. And even in method overriding, the semantic behavior should not change. It should do the same thing. But how it does it can be different in the subclass. So these are some of the differences between overloading and overriding. So in overloading, the argument types and order, they must change. In overriding, they cannot change. And the location of overloaded methods can be in the same class or subclasses. Whereas in overriding, you always override in the subclass. And the return types, exceptions and access, they can change from one overloaded method to the other. But in overriding, there are a few things that you need to keep in mind. For example, the return type, it cannot change except for covariant returns. Covariant returns means the return type is a subclass of the type that you are returning in the parent class. Okay. And then exceptions, you can either reduce or eliminate the number of checked exceptions. You cannot add more exceptions in the overridden method. And the access modifier, in overloaded methods, it can change. One overloaded method can be public and another can be private or another can be protected. But for overriding, it cannot become more restrictive than the base class. For example, in the base class, if the method is public, you cannot make it protected or private in the derived class. Whereas if it is protected or public in the base class, you can make it public in the derived class. So the idea is you cannot make it more restrictive than the base class method. Then the resolution for overloading is at compile time, whereas for overriding it's at runtime. And static methods can be overloaded, but static methods cannot be overridden. And final methods can be overloaded, but they cannot be overridden. Okay, so let's look at some examples now for both overloaded methods and overridden methods. So let's first start with overloading. So here I have a class called demo overloading, and I have like three overloaded methods called print. One takes string as an argument, another takes two string arguments, and the third one takes a string and a primitive int as an argument. And if you see, these are all instance methods which are all overloaded. So the parameter types always change. Okay. And if you notice, the access modifier can also change. One is public and another is protected. An overloaded method can be final as well. And here I have two instances of overloaded methods which are static. So overloaded methods can be static as well. Okay, and all of these, the semantics of each of these methods is print. So each one is printing what it is doing. So if you look at this demo program here, I create an object of this class and I can invoke it with each of those overloaded methods by passing the arguments that it expects. So when I say print here, it is taking a single string, so it will go and invoke the instance method called print, which takes a single string as an argument. If I pass two strings, it's going to invoke this. Again, it's a instance method, so it has to be invoked with the object of a class. And the third one invokes a method which takes a string and a primitive int as arguments. And finally, I am invoking two static methods which are also overloaded. One takes two strings, another takes a string and a primitive int. So let's run this program. And I see all the different print methods being invoked. Okay. First one is with one parameter, second is two parameters, both are strings. Third is two parameters, first is a string, second is an int. And the last two are static overloaded methods. Is output from the static overloaded methods. Now let's look at an example of runtime or method overriding, runtime polymorphism or dynamic polymorphism, which is done through method overriding. So I have a class here called employee, okay, and it has a method called calculate monthly wages. And then I have two classes called a security employee and a management employee. The security employee extends the employee class, so it inherits from the employee class, and it is overriding this method called calculate monthly wages. So you have to provide this annotation called @override, which informs the JVM that this is going to be overridden. This is an overridden method. And here I'm multiplying it by the hourly wage, which is 45 for a security employee, and for the management employee I do the same thing, but his hourly wage is 90. Okay, now let's look at a demo program. So in this demo program, I have initialized the number of hours worked as 160. So I'm creating a security employee and I'm assigning it to an employee object called E1, and I'm setting the name, SSN and email ID, and then I'm calling the method called calculate monthly wages. First of all, notice that the security employee can be assigned to an employee type because every security employee is an employee. So in an inheritance you have an is a relationship. So when the right hand side type has a is a relationship to the left hand side type, the assignment is valid. So you can assign a security employee to an employee. But when you call this, is there a method called calculate monthly wages on the employee object? Let's see. Yes, the default is giving 30, right? So if I multiply 160 by 30, I should get 48,000, right? 4800. So let's see what happens when I run this program. And here I'm doing it for the management employee whose hourly wage is 90. Okay, so let's run this program now. So you have 160 hours, and for the security employee the pay is 160 multiplied by 45, which is 7,200, and for the management employee it is 90, so we're getting twice that number. So what happens is at runtime it will see, so this is the reference to the object, but E1 is actually pointing to an object of type security employee. So it will invoke this calculate monthly wages from the security employee object. Okay, let's say, and similarly when I say here E2 is pointing to a management employee, it's going to call the method from the management employee. For example, let's say I create one more guy, employee E3, and I say equal to new employee. In this case, when I run it, let's run this. So default employee monthly pay. So now, since E3 is pointing to an actual employee object, it will invoke the method from the calculate monthly wages of the employee object, which is multiplying by 30. So let's run this. And now you see that it is giving a salary of 4800. Because E3 is now pointing to an actual employee object, it will invoke the methods when I invoke the calculate monthly wages. Since it's pointing to an employee object, it will invoke the method from the employee object. Whereas in the previous two cases, though it was of type employee, it is not going to invoke the calculate monthly wages from the employee object. It's going to invoke the calculate monthly wages method from the actual object it is pointing to. But this assignment is valid because the right hand side has is a relationship with the type of the left hand side. So this polymorphism or dynamic polymorphism, which happens at runtime, is implemented in Java via inheritance. So you need to have inheritance and override the methods for dynamic polymorphism. So some of the other things that I pointed out, the capabilities and the restrictions on overriding methods, you can try these out. For example, the return type you cannot change except for covariant type returns. Exceptions, try out exceptions, try making the access more restrictive and see what happens. So these are all your experiments that you can do to understand this more.